Questions 11 through 20 on the 2008 Grade 12 AMC 12B. A cone-shaped mountain has its base on the ocean floor and has a height of 8,000 feet. The top 1/8 of the volume of the mountain is above water. What is the depth of the ocean at the base of the mountain in feet? Here is a mountain, and the base is the black line at the bottom, and the water level comes up to somewhere. I'm not sure where, so let's say here. And what they are saying is that the full top to bottom height is 8,000 feet. So that was represented by this line. And of course, I will label that H. And then what they want us to figure out in this question is the depth of the ocean at the base of the mountain in feet, which would be this distance right here from there to there. And now they also tell me that the top 1/8 of the volume is above water. So this guy that is above water represents 1/8 the volume of the full mountain. So that's the information they've given us. So let's proceed. Let's do a little bit of labeling here. This top to bottom height right there, I'm going to call small h. And therefore this, which is what they want us to figure out, is represented by h minus h. That's essentially what we have to figure out the value of. The volume of any cone is given by the formula volume is equal to pi r squared times height, like that. And therefore, if this top guy represents 1/8, that basically means that 1/8 is equal to pi r squared h, where r is this little radius from there to there, all over pi big R squared big H, where r is that radius, that big R. And so far we just cancel out the pi's, and there's not much else we can cancel at this point. How we can cancel stuff is by finding a relationship between each of these variables. Now the good news is that one of these we know already. This one, we know it's 8,000. So this guy right here is 8,000. So that becomes 1/8 r squared h big R squared, 8,000. And I can bring the 8,000 over to the other side, and because 8,000 divided by 8, which is just 1,000, is r squared h all over r squared, like that. Now there's too many variables here. Obviously I'd like to eliminate some variables. How I do that is with similar triangles. The similar triangles is this guy and this big guy right here. As you can clearly see, those are similar triangles. So that means small h over small r is equal to big H over big R, right? Pretty straightforward relationship right there. And big H we know is equal to 8,000. So 8,000 over R is equal to H over R, like that. And we can rearrange this to suit our needs however we like. For example, small h over 8,000 is equal to small r over big R. And then I'll substitute this finding into this equation right there. And if I do, I get the following. 1,000 is equal to h over 8,000 all squared, small h, like that. And if you simplify, bring everything over, you get 1,000 times 8,000 times 8,000 is equal to h cubed. And I did it this way because it makes it easier. We've got 1,000 cubed times 64 is h cubed. And putting it in that form makes it easier to take the cube root, since we're not allowed to use calculators on the U.S. Math exams, on the American math exams. So this is just going to be 1,000 times the cube root of 64, which is 4, and therefore h is 4,000. And remember, we wanted to find big H minus small h, so that's going to be 8,000 minus 4,000, which is 4,000. And therefore, number 11, the answer is A. For each positive integer n, the mean of the first n terms of a sequence is n. What is the 2008th term of the sequence? So this sentence is the key to this question, of course. The mean of the first n terms of a sequence is n. So that basically means, for example, if you have one term, the mean is 1. So that means t1 must be 1. t2, we can figure out by understanding that if you have the first two terms, the mean is 2. So t1 plus t2, the mean will be equal to 2. Two terms, the mean is 2. Well, t1 we just figured out, so solving for t2, this gives me 4 minus 1, so t2 will be 3. All right? So this is how we will proceed. t3, the mean of the first three terms is equal to 3. So there we go. So that means we got 1 plus 3 plus t3 is equal to 9, and therefore t3 is equal to 5. So already I think you're seeing a pattern here. Let's just do a couple more, just two more. The mean of the first four terms, t1 plus t2 plus t3 plus t4, is equal to 4. So that means we've got 1, 3, and 5, so that's 9 plus t4 is equal to 16, and therefore t4 is equal to 7. And some of you have already figured out this pattern, but we'll just do one more. t1 plus t2 plus t3 plus t4 plus t5 is equal to 5, and therefore 1 plus 3 plus 5 plus 7, so that's 4 plus 12, which is 16. So 16 plus t5 is equal to 25, and therefore t5 is equal to 9. So by now you get the point here, you get the pattern. So that means that t to the n is going to be 2n minus 1. Okay, that's the general formula for t to the n. So they want you to figure out t to the 2008, and that's going to be 2 2008 minus 1, so that's 4015. And therefore number 12, the answer is B. Vertex E of equilateral triangle ABE is in the interior of unit square ABCD. Let R be the region consisting of all the points inside ABCD and outside triangle ABE, whose distance from AD is between 1/3 and 2/3. What is the area of R? Let's draw a diagram and explain this question. ABCD is our square, and inside the square we are to draw an equilateral triangle. So something like that, right? And they're saying that there is some region, R, that consists of all the points inside the square, but outside ABE, where this is E right here. So initially, that is our region, right? But then they give us an additional criteria that the distance from AD is between 1/3 and 2/3. So any point that we draw, its distance from AD has got to be between 1/3 and 2/3. Okay, well, they tell it's a unit square, right? So the length is 1 all the way from A to B. So if the distance is between 1/3 and 2/3, if we split up this into thirds, say 1/3, 1/3, and 1/3, the distance has got to be in this region right here. Does that make sense? So let's draw that in. So there we go. So that region is basically right here. This region, that is what we have to figure out the area of. So how do we do that? Well, I'm going to concentrate on this box right here. I'm going to draw a line top to bottom like that. And that rectangle that I just created, this one right here, I'm going to concentrate solely on that. So my region, R, is going to be that box minus this triangle, correct? And that's it. If I do that, then I'll be able to get this region which fits the criteria of the question. So let's take this one step at a time. First, let's look at this triangle right here. And the reason I'm going to look at that triangle is because I want to know this distance. If I can figure out that distance, I can subtract it from 1 to get this distance. And that will help me. Why? Because I have to figure out the area of that rectangle, its length times width. The good news is that one of the dimensions I already know is 1/3, right? This distance is 1/3. But I need to know this distance. So that is what I'm going to concentrate on. Then once I do that, then we'll talk about this guy right here. So first let's talk about this distance using this triangle. Well, we know that from here to here is 1/3 in terms of its distance. And this is a right angle. And this triangle that I drew in green is equilateral. So that means this is 60 degrees. And therefore this is 30 degrees. So for the 1000th time on a math contest, we again have a 30, 60, 90 triangle. And as you know, the ratio of the sides is 1, 2, and √3. Correct? So this side over this side, we can have a calculation based on the ratios. So this side, I guess I'll just call it x for now. X over 1/3 is equal to √3 over 1. So solving, we get x is equal to √3 over 3. Okay, so that means this has got to be 1 minus x. 1 minus x, like that. And x we just figured out. So this is going to be 1 minus x, which is 1 minus √3 over 3. Okay, so that takes care of the square, or the rectangle, I should say. Now we got to figure out the area of this triangle, this guy right here. Okay, so how do we do that? What I'm going to do is actually break it up into 2 by chopping it in half like this, just right down the middle. That's going to make it easier for me. If I do that, since this top to bottom there is 1/3, this is going to be half of that. So half of 1/3 is 1/6. Okay, so this distance right here. And then I need to figure out that distance. And I can do that yet once again with this 30, 60, 90. This is 90 degrees. This guy is 60, and that angle is 30. So if I call this distance, say, height, h, right, the height of the triangle, again, 1 over 6 over h is equal to 1 over √3. So therefore, √3 over 6 is equal to h. So we have to figure out this triangle. It's 2 of those little guys, or 1 big guy, whichever way, it's going to end up the same. 1/2 base times height. The full base is 1/3, and the height we just figured out was √3 over 6. So there we go. We're done. We just have to get it into some form that makes it look like one of the answer choices. Okay, so here we go. Let's see, 1/3, and then minus √3 over 9, and then this looks like √3 over 6 times 6, 36. Okay, interesting. I guess we have to get a common denominator. 36 is most likely. Multiply top and bottom here by 12. Multiply top and bottom here by 4 for √3. And then this one just is √3. And that leaves me with 12 minus 5 √3 over 36. And therefore, number 13, the answer is B. A circle has a radius of log of a squared to the base 10. And a circumference of log of b to the power of 4 to the base 10. What is the log of b to the base a? Radius is equal to log a squared to the base 10. Circumference is equal to the log of b to the power of 4 to the base 10. Well, circumference is equal to pi times 2 times the radius. So we substitute our equations into this guy. So pi times 2 times log of a squared 10, like that. All right, so let's continue. The log of a squared, we can bring these guys up here, 2 pi like that. Okay, that's part of the log rules. And this side stays the same. And then at this point, we can combine these, right, exponents. So it becomes a 4 pi log of that to the base 10. And this is the log of b to the power 4 to the base 10. Now, we can now conclude that b to the 4th is equal to a 4 pi, right? Basically just dropping the logs, so like this. Now what I'm going to do is just take the 4th power of everything, so I can get rid of that 4th power. And if I do, I just get b is equal to a to the power of pi. That's it. That's my final step of that equation. Now they want you to figure out the log of b to the base a. So the log of b to the base a is going to be the log, well, b is equal to a to the power of pi, so substitute that in, a to the power of pi, base a. The pi then becomes in front, a to the base a. And then this, if you remember, is equal to 1. And therefore this simplifies to just pi. So number 14, the answer is C. On each side of a unit square, an equilateral triangle of side length 1 is constructed. On each side of each equilateral triangle, another equilateral triangle of side length 1 is constructed. The interiors of the square and the 12 triangles have no points in common. Let R be the region formed by the union of the square and all the triangles, and let S be the smallest convex polygon that contains R. What is the area of the region that is inside S but outside R? There's several ways of approaching this question. I'm just going to do it my way. And that is, first and foremost, this is the diagram, right? And we have to understand that these triangles all represent the 12 triangles that they are talking about right there. And then the original square is in the middle, right there. And then, of course, what they've done is they've joined the edges like that. And that creates this convex polygon that they refer to. And what we have to figure out is the area of these shaded regions. I don't know if you can see that these are shaded. These guys, these 4 triangles are shaded, and we have to figure out the area of that shaded region. So each of these I will just call R, like that. And then at the end, I will calculate 4R, which of course is the total area of that shaded region. So how do I figure out R? Well, what I'm going to do is I'm going to connect these like that. And if I do that, I hope you can see that this allows me to sort of subtract a few triangles and get the region R. So I'm going to concentrate on this square right here. That square will allow me to figure out R. And what is R? It's going to be the square minus the 3 little triangles, and I'll call them 1, 2, 3. 1, 2, and 3, like that. So the square minus 1 minus 2 minus 3 will give me R. And then I multiply it by 4, and I'm done with the question. All right? So I hope that makes sense. So some of these dimensions are easy, but some of them will require a little bit of mathematics. First dimension that's relatively easy is this from there to there. That's just 1, right? Because this was 1 because it's a unit square, and these were all equilateral triangles. So all of those sides are equal to 1. So this is 1. If that is 1, which it is, that means this distance is a half. So first put that half right there. And then top to bottom here, That I can figure out using my 30, 60, 90 triangle deal for the 1000th time. And by now, you probably have it memorized that you've got 60, 30, then we'll just call this side h for now, and this is a half, right? So h over a half is the same as, if you remember, root 3 over 1. So h is equal to root 3 over 2. And some of you don't even need to do that. You can just immediately do that in your head for a unit triangle. So this is root 3 over 2 right there. All right? That distance. And then in a very similar way, this from here to here is, of course, identical to what we just did for number 2. It's the same, so we don't really need to do it, but just for simplicity, completion, I should say, that's root 3 over 2 from here to here, and from here to here is a half. Okay, now all we have to do is find that dimension, and then we can proceed. Well, that dimension right there, we have to figure out from the fact that this is root 3 over 2, and this is a half. So this, basically, is root 3 over 2 minus a half. Root 3 over 2 minus a half. That distance right there. Okay? And that's it. We're pretty much done with our dimensions. So now we can proceed with r. It's the square. The square is going to be, let's see here, root 3 over 2 squared, right? Then 1. 1 is 1/2 base times height. Well, the base and the height are the same. So it's root 3 minus 1 over 2 squared. And then minus 2 minus, well, 2 and 3 are identical. So it's going to be minus 2 times 1/2 base times height. The base I can call a half, and the height root 3 over 2. And there we go. Now I just have to make it into one of these forms. So let's see what happens. This becomes 3 over 4 minus root 3 minus 1 squared over 4. And this is minus root 3 over 4. Yeah. Okay, I got to expand all this. Okay, so let's see here. This looks like 3 minus root 3 all over 4, and then I've got to do this expansion here. So 3 minus 2 root 3 plus 1 all over 8. Get a common denominator. This becomes 6 minus 2 root 3 minus 4 plus 2 root 3 all over 8. And looks like the root 3's cancel, so I'm just left with 2 over 8, which is 1 over 4. Okay, and that equals r. And my shaded region, remember, is 4r, so please don't forget to multiply it by 4. Remember, there was 4 of these guys, right? So 4r is going to be equal to 4 times 1/4, and that is 1. So number 15, the answer is C. A rectangular floor measures A feet by B feet, where A and B are positive integers with B greater than A. An artist paints a rectangle on a floor with the sides of the rectangle parallel to the sides of the floor. The unpainted part of the floor forms a border of width 1 foot around the painted rectangle and occupies half the area of the entire floor. How many possibilities are there for the ordered pair AB? Let's draw in our rectangle. And this is B and this is A. And keeping in mind that B is greater than A. And then the border is always going to be 1, right? That's 1, that's 1, that's 1, that's 1, like that. So this distance here is B minus 2. And this distance here is A minus 2. And they tell me that when I take the dimensions, the small rectangle, which is A minus 2 times B minus 2, is equal to half of the big rectangle in terms of area, which is b times a. So this is the equation that we have to work with. And you can do this several ways. I'll just show you a little bit of a factoring technique. So first let's just expand this. This becomes ab minus 2b minus 2a plus 4 is equal to a half ba over 2. And then of course multiply through 2ab minus 4b minus 4a plus 8. And then bring the ba over. So we get ab minus 4b minus 4a plus 8. Now we can kind of start plugging in, but it's easier if we have something factored. The way you can factor this is a neat little trick, is just add 8 to both sides like this. If you do that, then you'll see this becomes ab minus 4b minus 4a plus 8, and then this can factor right here. That is 8, and this factors into a minus 4 times b minus 4. And once you do that, this becomes very straightforward in terms of trying to figure out a and b. So we make a table. We got a, we got b, a minus 4, and b minus 4, like that. And you have to understand that if you multiply a minus 4 and b minus 4, they have to equal 8. So there isn't much in terms of possibilities of doing that, and they also tell you that those are integers, correct? They tell you that they're integers up there, positive integers. There we go. All right, so here we go. Let's proceed. A minus 4 times b minus 4. What are the possibilities? Well, 8 and 1, that would do it. 4 and 2. But what about 2 and 4 and 1 and 8? No. Why? Because please keep in mind that b is greater than a. That is a very important condition that they tell you in the question right there. Otherwise, you'll get double the number of answers. So these two cannot be used. So let's figure this out. Pretty straightforward. If a minus 4 is equal to 1, that means a is 5. If b minus 4 is equal to 8, then b is 12. If a minus 4 is equal to 2, then a is 6. And if b minus 4 is equal to 4, then b is 8. And that's it. These are the only two ordered pairs that satisfy the conditions of the question. So number 16, the answer is 2, and that's choice B. Let A, B, and C be three distinct points on the graph y is equal to x squared, such that the line AB is parallel to the x-axis and triangle ABC is a right angle with area 2008. What is the sum of the digits of the y-coordinate of C? Let's draw a little graph and see what this looks like. So we've got x and y planes, and then they're giving us y is equal to x squared. So that's a parabola, right? So it's something like this. Something like that. And it goes on forever. Okay. So this is y is equal to x squared. Now they're telling me that we've got 2 points, A and B. So let's make this A and make this B. And if you draw that line AB, it is parallel to the x-axis. So like that. Does that look parallel? Yeah. So it's parallel. So I'll draw little parallel lines like that. Okay, so far so good. And then C, we got to put C somewhere. So I don't know where C is going to be, but let's just put it somewhere for now. Let's say it's here, right there. And they're saying that you will form a triangle ABC. So this is A, this is C, and this is B. And they're saying that that is a right triangle. So based on this diagram, I'm pretty sure that the right triangle is the 90 degrees being at C. Otherwise, I don't see how it could be here or here. All right, so this is the setup of the question. And let's proceed. Now I've got to give these guys coordinates, right? So B is going to be some coordinate. Let's just call it, whatever you want to call it is fine. We'll just call it B or A. I mean, the letter that you choose is not important, but I'll just call it A. Now, because it's on this graph, the y coordinate will be of the form a squared. Correct? So there you go. Similarly, A, because of the symmetry of this diagram, will be minus a squared. Right? Because AB is parallel, it has the same y coordinate. And then C, I have no idea, so I'll just call that C squared, like that. Or any letter you want. I actually, for some reason, I prefer to use X. C just, I don't know why, it just seems weird. But whatever, the letters are not important. The setup of the question is important. Now, you have to keep in mind that these two lines, this guy and this guy, are perpendicular lines. That's what that 90 degree means. So their slopes will be negative reciprocals. You remember? Two perpendicular lines have slopes that are negative reciprocals. So let's figure out the slope. The slope of AC, that's going to be x squared minus a squared all over x plus a, right? Everybody knows how to calculate the slope of a line, so I'm not going to walk you through that. Slope of CB, a squared minus x squared all over a minus x. Now these are negative reciprocals, so if one is, let's say, m, the other one is negative 1 over m, like that. So that means x squared minus a, x plus a is equal to, flip it and then do a negative. So minus a minus x over a squared minus x squared. Okay? And then now at this point we have to simplify this. So let's see here. Cross multiplying, we get x squared minus a squared. And then that's going to be a squared minus x squared. And then cross multiplying, get x plus a. And that looks like it'll just be x minus a if you multiply through by negative 1. All right, so far so good. No tricks in this one. Now this guy here, if we multiply that out, we get x squared minus a squared. And this is x squared minus a squared. And this is a squared minus x squared. And as you can see, this is the same as that, so those cancel. So all it leaves us with is just a squared minus x squared is equal to 1. And that's very important. A squared minus x squared is equal to 1. Why is that important? Because that signifies something on the diagram. It is representing the height, this height right here, from C, a perpendicular drawn right there. That height, which I will just call h right there, that height, if you look at it, is a squared minus x squared, correct? From the coordinate system. And that, they're saying, is equal to 1. Or that is what we figured out, or I figured out, is equal to 1. So now we can look at this piece of information that the area of the triangle is a half, and that will allow us to solve the question. So the area is 2008 is what I meant to say. So we got area is 1/2 base times height, and the base of that triangle is AB. The height is h, and 2008, and therefore 1/2 AB in terms of our lettering is what? AB is equal to 2a. And then height we just figured out was 1. So this basically means that A is equal to 2008. That's it. And now we can figure out, using this formula, x. So a squared minus x squared is equal to 1. A squared, which is 2008 squared, minus 1 is equal to x squared. So x squared is equal to 2008 minus 1. So that's 4032,063. And x squared represents the y coordinate of C. Correct? Right there. And they want you to figure out the sum of the digits. So the sum of the digits are 4 plus 3 plus 2 plus 6 plus 3. And that is 9 plus 9, which is 18. So number 17, the answer is C. A pyramid has a square base, ABCD, and vertex E. The area of square ABCD is 196, and the areas of triangle ABE and triangle CDE are 105 and 91 respectively. What is the volume of the pyramid? Of course, let's draw the diagram. So first, I'm going to draw the base, just the base, and that base is ABCD. And the good news is that they tell us that it has an area of 196. So it's a square, and I've drawn it slightly curved or slanted because I have to draw a pyramid eventually. But they tell me that ABCD is a square. All right. So because it's a square and its area is 196, and the area of a square is always calculated by the side squared, the side is equal to 14. So I can immediately label these guys 14. 14, 14 like that. And now let's draw in the pyramid. So the pyramid is going to look something like this. And the reason it's slightly tilted like this is because these triangles don't have equal area. You notice that one is bigger than the other. So this one, ABE, is 105. So it's got to have a slightly taller height or longer height, whatever term you want to use. And then the other one, triangle CDE, this guy right here, that area is 91. Okay, so far so good. So I will draw in the heights on each of these triangles. So there you go. I'll call this height H1, and then this height I can call H2 is fine, I think. Okay, so now let's use this piece of information to figure out the heights. For ABE, that triangle, its area is, of course, 1/2 base times height. And the height we have called H1. They tell me that ABE has an area of 105, 1/2 base. Well, what's the base? Base is 14. So 14 times H1. And therefore, solving for this, we get H1 is equal to 15. All right? And very similarly, we can figure out H2 with triangle CDE. That is, again, 1/2 base times height. The base is 14. And the height we are calling H2. And they tell me that's 91. So 1/2, 14, that's 7. So 7H2. So that means H2 is 13. All right. So those two calculations are fairly straightforward. Now we have to figure out the height of the pyramid. And the pyramid's height is going to help us calculate the volume of the pyramid. This top to bottom big red line is the height of the pyramid. I'll call it just big H. And then you notice I drew a line connecting this H2 to H1. And that's very important because that helps us establish two Pythagorean relationships. From here to here, I'll call that x. And then from here to here, that is 14 minus x, of course. And here we go. We can now use this triangle and this triangle to figure out our value of x and h. And then once we have h, we can figure out the volume of the pyramid, which is 1/3 the base times the height. All right, so here we go. So our first Pythagorean relationship is h squared plus 14 minus x squared is equal to h1 squared, like that. And h squared plus 14 minus x squared is therefore equal to h1 we figured out was 15, so that's 225. The next Pythagorean relationship with the other smaller triangle is h squared plus x squared is equal to h2 squared. And h2 we had calculated, and that's 13, so 13 squared is 169. So there we go. So I can call either one. I can call this equation 1. I can call this equation 2 right here. And then if I do 1 minus 2, that should give me the opportunity to solve for one of these variables. All right, so 1 minus 2 will give me 14 minus x all squared minus x squared. And on this side, 225 minus 169, which is 56. Expanding, I get 196 minus 28x plus x squared minus x squared is equal to 56. So that means 196 minus 56, so that's 140, is equal to 28x. And therefore x is equal to 5. And I can substitute back into any of these to figure out h. h squared plus x squared, so that's 25, is equal to 169. Therefore h squared is equal to 144. And therefore h is equal to 12. There we go. We just got the height of the pyramid. So our volume, therefore, is 1/3. The base is that square. And they even tell you the base has an area of 196. So there we go. The height we just got was 12. And therefore our volume. So this calculates to 784. And there we go. Number 18 is the answer. The answer to number 18 is 784, which is choice E. A function f is defined by f at z is equal to 4 plus I z squared plus alpha z plus gamma for all complex numbers z, where alpha and gamma are complex numbers and I squared is equal to -1. Suppose that f at 1 and f at I are both real. What is the smallest possible value for the magnitude of alpha plus the magnitude of gamma? F at z, they tell me, is 4 plus I z squared plus alpha z plus gamma. And then they give me two important clues that if I figure out f at 1 and f at I, they will give me real values. That means there will be no I component. All right, so let's figure out what is f at 1. If I put 1 for z, it will give me 4 plus I plus alpha plus gamma. Yeah, I think that's it. And then if I put f at I, this guy right here, that gives me 4 plus I squared plus alpha times I plus gamma. And then simplifying this becomes -4 minus I plus alpha I plus gamma, like that. Okay, well, alpha and gamma, those are both complex numbers, so we've got to put them in that form. So I'll just let alpha equal to A plus BI, and gamma I can equal C plus DI. And let's substitute those in. So this is some real number. So 4 plus I plus A plus BI plus C plus DI, like that. And therefore, collecting like terms, first collect the real terms, 4 plus A plus C, and then let's collect the imaginary terms and put them in brackets, factoring out the I, 1 plus B plus D. And then I'll explain later why I've done that. And then exact same way over here. So we've got -4 minus I, and then alpha, which is a plus bi times I, plus gamma, which is c plus di. And in a very similar way, let's expand this out and collect like terms. So ai, and that's going to be minus b plus c plus di. Collecting like terms, we get minus 4 minus I minus b, I should say, plus c. And then factoring out the I, we get I times minus 1 plus a plus d. All right, there we go. And this is also real. So what does that mean if something is real? It means that the imaginary component here is 0. That means this has to disappear. Real numbers cannot have imaginary terms in them. So that basically means the following, that this here has to be 0. So 1 plus b plus d must be 0. And in the same way, over here, it means that this guy here is 0. So minus 1 plus a plus d has to be 0. Okay? Solving for this, I'm not really sure, but what we are supposed to do in terms of solving, we can isolate for one variable. Similarly, we can isolate for one variable here. And let's see what happens later on. So now we have to figure out the value of that. Now, these lines do not mean absolute value, they mean magnitude, all right? Because they look like absolute values, but because we're talking about complex numbers and alpha and gamma are complex numbers, this is magnitude. So we have to figure out the magnitude of alpha plus the magnitude of gamma. And how do you figure out the magnitude of something? Well, here's alpha and gamma. The magnitude is equal to a squared plus b squared for alpha. And then for gamma, it's c squared plus d squared, like that. All right? So far, I think that was fairly straightforward. Complex numbers can be difficult, especially on math contests, but I think this one so far is not so bad. Now we have to figure out the value of this, but in particular, they want the smallest possible value. So not just a value, but the smallest possible. So how do we do that? Well, that's when these guys come into play. These findings, that's going to help us. So first, let's just substitute those in. So for a, it's minus d plus 1 all squared. And for b, it's minus d minus 1. And this just becomes c squared plus d squared. I think this we can leave for now. If I expand this and collect like terms, I get 2d squared plus 2. And this guy over here just stays the same. Now I want the smallest possible value of this. The smallest possible value of this will occur when d is equal to 0 and when c is equal to 0. And if that is the case, this just becomes root 2. That's it. And if you remember, if you go back and check out alpha and gamma, alpha was what? It was a plus bi, right? And gamma was c plus di. So that means that alpha is a plus bi. Well, we got to figure out a and b. We don't really need to, but I just wanted to show you. B is going to be -1 and a is going to be 1. So alpha is 1 plus I, and gamma looks like it's just 0. Interesting. Well, it doesn't matter. They want us to figure out the smallest value of this, and we did that. It's root 2. So the answer to number 19 is root 2, which is B. Michael walks at the rate of 5 feet per second on a long straight path. Trash pails are located every 200 feet along the path. A garbage truck travels at 10 feet per second in the same direction as Michael and stops for 30 seconds at each pail. As Michael passes a pail, he notices the truck ahead of him just leaving the next pail. How many times will Michael and the truck meet? Let's begin. This is going to be time in seconds. This is going to be Michael's distance from point 0, and this is going to be the garbage truck and the distance of that truck. And they tell us that Michael is traveling at 5 feet per second and the garbage truck is traveling at 10 feet per second. But one important point in this question is that the truck stops for 30 seconds at each pail, so that needs to be taken into consideration. So let's begin. Time 0. Michael is at 0, but the garbage pail, or garbage truck I should say, it starts actually ahead, right? They say that in the question, that as Michael passes a pail, he notices the truck ahead of him just leaving the next pail. So I'm calling that sort of time 0. That's where my calculations begin. So the garbage truck is already 1 pail ahead, and the pails are located 200 feet from each other. So the garbage truck, I keep saying pail, is going to be at 200 feet ahead. That's time 0. Now, our time intervals initially will be 50 seconds. Why 50 seconds? Because it takes 20 seconds for the garbage truck to travel the 200 feet to the next pail, correct? Because it's 10 feet per second. So 10 feet per second times 20 seconds is 200 feet. And that's how long it takes for the truck to travel. But once the truck reaches the next pail, it stops for 30 seconds. So 20 plus 30 is 50 seconds, and that's the time interval that we need to look at. So when that happens, this garbage truck will be at 400. But what about Michael? Well, he just keeps going. He doesn't stop. So his calculations are actually easier in our head. It's just 50 times 5 feet per second, which is 250. All right, let's keep going. The next 50 seconds, but I want a cumulative time here. So 100, right? Another 50 seconds, but cumulatively it's 100 seconds that have passed since time 0. Michael is now at 500, but the garbage truck is now at 600. Okay, for the exact same reason as before, as discussed before. Now another 50 seconds go by. Michael's now at 750. Truck is at 800. Another 50 seconds go by. Michael is now at 1,000. Truck is now at 1,000. There we go. They meet for the first time right here. Okay? So that's what they are asking, is how many times do they meet? So eventually I'm assuming that Michael's going to go running away. He's going to exceed because somehow, some way, I think the garbage truck will fall behind eventually because of all the 30-second stops. Well, let's see what happens. So we continue, but at this point, things are going to get a little intricate. So instead of jumping every 50 seconds, I'm going to only jump every 10 seconds because they're going to be meeting several times. We don't know. We have to figure out how many times. They're going to meet at least four to 8 times. So we have to figure out every single one of those little tiny moments that they meet. So 10-second intervals, I think, should be good enough. So in 10 seconds, he travels 50. The garbage truck travels 100. So there we go. 220. Another 10 seconds go by. Now Michael's at 1100. The garbage truck is at 1200. Now, for the next 30 seconds, 230, 240, and 250, the garbage truck does not move, right? Remember, it stops for 30 seconds. So the garbage truck will remain at 1200 like that for the next 30 seconds. Okay, that's an important part of the question. But Michael keeps moving. So he's going to be at 1150, 1200, like that. Well, before I keep going, they meet right there. See how they match up there and they match up here. All right, great. So we got 2 so far. Michael keeps going. Now he's at 250. Michael is now ahead of the garbage truck. I believe that's the first time that Michael's been ahead of the garbage truck, perhaps, I think. All right, let's just keep going now, again by tens. 260, 270, 280, 290, and 300, like that. Well, Michael just keeps going. His calculations are relatively straightforward. 1300, 1350, 1400, 1450, and 1500, like that. Okay? But the garbage truck, a little bit different, right? Initially, for the first 20 seconds, it moves. So it goes 1300, then 1400, but then it stops for 30 seconds. So for the next 30 seconds, it's not moving. All right, now let's go back and see if any of these match. Yeah, this matches right here. And this matches also. So there's 4 so far that we found. Let's see how many more we can find before we can obviously see that they're never going to meet again. Well, let's just keep going by tens. 310, 320, 330, 340, and 350. Michael moves along at the same pace, 550, 1600, 1650, 1700, and 1750. The garbage truck is a little bit different. It moves for the first 20 seconds, so 1500, 1600, but then it stops for the next 30 seconds. Anything in common in this segment? And the answer is yes, right here. That's when they meet. Let's jump ahead. Now notice Michael is 150 feet ahead of the garbage truck, and I think that's it. The garbage truck is not going to catch Michael anymore. Because if you go to 400, Michael will be now at 2,000, and the garbage truck will be at 1,800. If you go another 50 seconds, Michael will be at 2250 and the garbage truck will be at 2000. And you notice Michael's getting further and further away. So that's it. These are the only meeting points, and that is 5 meeting points. So therefore, for number 20, the answer is B.